Good afternoon. Chris Riviere with Cisco's Cloud Security Unit, Technical Solutions Architect. One of the kind of interesting points that I find talking about DNS, right, is maybe we'll just start off with a question. Anyone have any ideas how many DNS queries a user makes per day, right? Just maybe on average, anyone in here?
Hundreds, maybe thousands.
Okay. Yeah. Anyone else?
Thousands.
Okay, yeah, actually, yeah. So we find on average it's between 2,000 and 3,000. Now, obviously, that's going to depend on what type of user you are, how many hours you work, what you're doing, how many devices, et cetera. But I think it's kind of an interesting statistic. And lots of times when you actually have these conversations with enterprises, I'll talk to people and say, if someone in your organization goes to Facebook.com, right, or goes to any sort of external domain, do you have any visibility into that? And lots of times, companies aren't sure. And quite often what you'll see is depending on organizations, they may have different types of deployments, right? They may have a location in Europe they just use their ISP to do the DNS. They might have another office in Asia, and the local team out there decided to point to Google 8.8.8.8 for resolution. They may have some other sorts of appliances. And then if you think about the users, everyone now is on a laptop right now. I imagine you have some sort of protection and stuff. And when you go into your company, lots of times there's firewalls, et cetera. But then what happens when you take your laptop home, right? What happens when you go to one of your customer sites? What happens when you go to a cafe, right? Lots of times you lose some of that security protection that you have on-prem. So this is just kind of an interesting point in terms of the value of a recursive DNS service, right? So that's what we are, a recursive DNS service that provides security at that layer. So there's just lots of value in having a recursive DNS. Lots of times you'll have different ISPs. Users get different experience when, depending on who their DNS provider may be. So this just gives you a simple way to point to, we have Anycast IP addresses. You point to those Anycast IP addresses. We have over 30 data centers globally. You're guaranteed to get routed to the closest data center to get the fastest response. Which also provides a consistent way to do policy enforcement, right? Which I'll start talking about and enforce security. Really quickly here, this is just a quick slide showing some third-party validation. You can go to dnsperf.com. You can select a region if you click public DNS resolvers in the center. And this just kind of shows some global DNS providers and the query speeds on average. What I think is interesting about this is, we're right up there, number 2. That's Cloudflare up there, slightly faster. They have more points of presence. But we're right there, about 15 milliseconds. Google's about 25 milliseconds. There's some other ones that are slower than that. So I think it's just kind of interesting in terms of when you're, again, talking to people, do you want that visibility? Yes, you can point to a recursive DNS provider, a global recursive DNS provider, and now get consistent DNS performance. This is just another study from Thousand Eyes with a kind of similar breakdown on speeds. But the real takeaway from this is you can point to, Google, you can point to Cloudflare, and the idea is if someone gets infected with malware and they're reaching out to a command and control server, well, guess what? Those services are going to tell you, here's the IP address that you're requesting, super fast. But what they don't provide is they don't provide the ability to do any sort of blocking, policies, and no visibility, right? So we actually do offer a completely free service. It's called DNS monitoring. You can go to dnsmonitoring.umbrella.com. You can sign up 100% free, point your traffic to us, no rate limiting, and we'll now give you some sense about all that DNS traffic. So if you think about those 3,000 queries per user, now you can picture what kind of intelligence that actually provides you about your own organization, right? Hey, maybe this location in New York is using Slack. This location in Miami is using, WebEx Teams. This other location is using something different, right? So it actually gives you a lot of interesting statistics about what the users are doing. And as I was mentioning, it becomes a simple mechanism to enforce security. Because we have all this traffic coming to us, and I'll talk about that in a little bit. It's such a fundamental protocol, DNS. One of the nice things about it, it's actually really easy to point your DNS to us externally. And it provides an effective layer of security. Lots of times I've worked with customers where they have these bespoke systems that they've created. Maybe it's like healthcare or hospitals, manufacturing facilities. They have these bespoke devices. You can't put agents on those, right? They run out-of-date operating systems. They're not proxy aware, but lots of times those are still leveraging DNS if they have to reach out somewhere. So this becomes an ideal mechanism to actually provide security malware, command and control, phishing, etc.
This is all public internet, right? So we've got BlueCat doing my private network.
Exactly.
All the operations, all the functionality, all the capabilities. And now we're just talking about Cisco Umbrella, which is the public DNS, which BlueCat can chain into as needed.
Exactly. We do not want to know any internal domains. We're not going to know how to resolve them.
No, that's fine. I just wanted to set the picture because I think sometimes that gets lost when we suddenly start talking about Umbrella, and we've transitioned topics, so I want to cover it.
Yeah.
So I think we alluded to this a little bit earlier, but it's quite simple to point your DNS to us, and lots of times it might just be an Active Directory server, local bind server, and you say, okay, I want to forward those DNS queries to Umbrella. You put in our two Anycast IPs, and boom, you're going to get faster resolution, and it provides a mechanism to enforce security and content. However, there are different synergies. Obviously, within the Cisco ecosystem, there's some synergies, whether you may be using ISRs or Viptela wireless LAN controllers. The Meraki one's quite interesting. So Meraki will actually will encrypt the traffic. It will send the SSID and the private IP address of who's making the query, right? So it kind of gives us additional attribution. You're still getting the same layer of security. We do have integration with Active Directory, et cetera. And of course, there's for off-network protection, right? So again, I was talking about lots of times when users are on-prem, they're being protected by firewalls, proxies, et cetera. So now when the user goes off-network, we have integrations with AnyConnect, so we can detect when the user is not on a corporate network. And what we'll do is we'll actually encrypt all their DNS traffic and send them to the resolver. So now you get consistent policies for users on and off network. We also support Chromebooks. We have a standalone client for Windows, Macs. And if you do, this is kind of via our partnership with Apple. If you are running supervised, managed iOS devices, you can actually ensure that don't have my phone with me, all your DNS queries for your phone, no matter what network they're on, 2G, 3G, 4G, 5G, that those queries are going to our resolver, and you also have those policies. Now, that's, again, only for supervised and managed iOS devices from a privacy.
Is that all still DNS over UDP, like legacy DNS, legendary DNS?
It's still DNS.
Not DOH?
No.
Right.
Well, I'm not a storage guy, but
Oh, you are. You are. That was funny.
so the data you actually capture is kind of dangerous, right? You capture a whole lot of, whatever website, whatever DNS calls people are doing. So besides the security aspect of using that data, what else do you do with that data?
Don't think there's anything. We don't use it for any other purposes.
But
Sure, we have some privacy legal statement that says
there-
more.
What do you do with the data then? Is it,
Well, so that you have the data available for you to look at as a customer, right?
Well, but do you delete it after an hour? Do you save it at all? What's the
Yeah, so we
data
have some
compliance part of
options.
it?
I'll show you in the demo. There's actually some options that you can set yourself in terms of what's actually logged. So some cases you may choose not to log it, and it won't be logged.
And I would just say, and I don't care. I'm as concerned about privacy as anyone. It's one of the reasons why I'm actually not a Doe or Dot fan. I think they're not actually real privacy because we're just transmitting who we're sending queries to some other group that's going to then sell it down the road. But what I've seen Cisco use it for in the demos they presented to us is really for doing more security studying. And let's remember that we're deploying this on an enterprise, right? I mean, when you work for an organization, they're trying to protect themselves, and this is a really good way to, like I said, you stop a DNS query from happening. You're not doing any of the follow-on transactions. You're not going to download the malware. You're not going to go to the phishing site. So there's a lot of benefit in doing it at this layer. And again, I definitely understand the concern for privacy. One of the nice things about the BlueCat integration is our ability to keep your on-premises DNS on-premises. But when you go to the public internet, you want that protection, I think.
So I let me follow that again. What is your stance on DNS over HTTPS? Because it said first you said you didn't, but then you said you want that privacy. So what is the?
I don't like DNS over HTTPS
Period.
at all.
Full stop.
I think it is a bad solution, and I think it's being misrepresented. Sorry, we're way off topic, but
No. This is very interesting because
I think it's being
people talking about it.
misrepresented to the average consumer as a privacy for them, when in fact all you're doing is transmitting who you're trusting today, which is your ISP, which no one should trust, to some other entity. Maybe it's, and again, there's different organizations, which I don't want to call them
Whoever's
out.
got the DNS server gets the data.
Exactly.
I want you to get that data. I want you to support it.
Exactly.
But that's
So-
different. That's an implementation detail, not a.
That's fair.
Let's go back to.
Yeah.
Sorry.
But the kind of takeaway from this is, we worked in a bunch of different complex environments, done various sorts of deployments. There's one, we can deploy in these different environments. Now, specifically with the BlueCat integration, right? We're just talking about, this is some actual screenshots of how that integration works. So one of the things that they're leveraging is our network device API, right? So typically with Umbrella, what you do is you point your traffic to us and you register your egress IP address. Well, what they're actually doing is they're generating an API key, pasting it in their UI, and then that traffic from the BlueCat appliance service point is going to be sent to us. And you can actually see here's some registered appliances here. And then this is the real value of what you get down here, the additional attribution, right? So you can see here the external IP of where these queries are coming from. But what's more interesting here is the internal IP address. And that's the real interesting bit of information. If everyone in this room right now, and we were like, oh, someone's infected with some sort of malware, we see it's coming from this room, that's really not going to help me. I want to know who exactly in the room, right? I'm going to need some additional bit of information. And so that's the kind of crucial bit of information there, that internal IP address. So how we're kind of built into the foundation of the internet, the idea is we see a bunch of traffic, over 200 billion queries every day, and we're trying to make sense of it. So when we see those queries coming at us, where the idea is we can quickly determine, is it good, is it bad? But we've actually, over the years, built out a bit more than that. So we've built in what's called an intelligent proxy. So we do have the capability for our users where if a site, if we're unsure of a site or if it's a newly seen domain, that is, we see about 3 million newly seen domains every day. That's a domain we've never seen before. What we can do is we can actually proxy the traffic to that domain through our proxy, where we can do virus scanning, check files downloaded against our AMP database, et cetera, to determine if the traffic could be malicious. So the idea is to really provide this security capability for users, whether they're on or off the network. Now about some of the information that we see, this is more like my favorite stuff, because since I was working here, I always got interested in terms of how exactly did we determine if something's bad, right? So what we do is we see around 200 billion queries every day. And what's quite unique about that is, I'd say, the scale, but not only the scale of that data, but the diversity of the data. If you think of a user when they're on a company network with firewalls and proxies, they're probably going to go to more corporate-y sites, right? But what actually happens is it's when users go off network, when they're on a public Wi-Fi, when they're at home, that's where they go to the kind of more dangerous parts of the internet. We typically see that with gambling traffic, with like gambling, adult sites, streaming media sites, right? Someone wants to watch the latest Game of Thrones episode or a football game in another country, et cetera. So they start Googling and they're taken to these dodgy infrastructure where those sites are streamed. What happens is they get infected when they're off the network, and then they go bring their laptop back on the corporate network and things kind of spread. So what's unique about this is over 100 million daily active users, but again, that traffic is coming from over 18,000 enterprise customers, but also all the free users, right? So we have free services at home. You can, block adult content completely free by pointing your DNS to us at home. We have a large, diverse base with users in over 190 countries. What do we actually see at that? What kind of intelligence are we able to gather at this level? We're able to, if you think about it, we're seeing those external queries, right? So we're seeing those queries. Maybe they're sent from the BlueCat appliance. What information can we see about who's making that query, right? We're going to see things like, if this is a domain we've never seen before, we can say, that's a brand new domain on the internet. Let's say that we see, if it's a phishing domain, we can infer, hey, this user, may have clicked a link on a phishing domain. Or, command and control callbacks could be indications of compromised systems, right? Why all of a sudden is we see someone reaching out to, looks like a completely randomly generated domain name, we can infer, hey, that looks like a command and control request, right? So that's kind of the intelligence that we see of who's making those queries, right? What countries are the users coming from, et cetera. But now, at the end of the day, we're a recursive provider, which means we actually at first don't know the IP address. So we have to go to the authoritative source to actually find out what that IP address is. Now, this actually gives us a completely different view of what's happening to the back-end infrastructure, right? So let's say you're querying your bank.com and we always see this IP address. All of a sudden, it goes to a completely different IP address, right? We're able to kind of see that. We're able to kind of see that change. We're able to see things like fast flux domains, right? It's a domain constantly changing from one IP address to another IP address. We're able to kind of see the newly spun up infrastructure, right? So we know where things are. We know where there's like bulletproof hosting providers out there, et cetera. So we have these kind of two views of the internet. We have who's making all these queries, what types of queries they're making, how many queries they're making, and then we're kind of like mapping out the infrastructure on the back end. So we know where these domains are, which IPs they've been at, how long they've been there, what's the who is information, all this other information. So that's just kind of setting the stage for the amount of information that we have. And then if you talk about what we actually do with this information, this is actually where it gets really interesting. So we actually have a team. This is where we kind of tie into Talos. We have a team of research people with PhDs, like literally studying this information, coming in 200 billion queries a day, trying to identify patterns, right? How can we identify trends of this? What could make this malicious? And how can we actually identify this at scale, right? And even leveraging things like artificial intelligence and stuff to identify some of these domains. Now, in addition to that, we have a whole team of analysts, and I look at that as more the people in the loop, right? So they're hooked into the security community. They're looking at things like false positive reports, et cetera. And so they're there as well, and the two kind of keep each other in check. And this is, I think, one of the biggest differentiators is our actual threat intel, right? Because lots of people can provide, say you're providing security at the DNS layer, but they don't have the 200 billion queries a day with the broad diversity of the global traffic that we're seeing to actually make some of these decisions. So some of the things we can do is we actually have like these algorithms. There's dozens of these to do things like DGA prediction, right? Looking at the likelihood of a domain if it was domain generated algorithm. Punycode, if you're familiar with that, right? That's where you have foreign characters that are made to look like real characters from a phishing perspective, right? Being able to look at these domains and say, hey, this looks like it could be phishing or not. So there's basically heaps of these that are constantly running on a regular basis, and we're constantly convicting all these different domains. And the best thing about this is, we're seeing over 3 million newly seen domains every day. We're identifying over 60,000 malicious destinations every day. And at any point, we're blocking more than 7 million malicious destinations. And you get that protection just by pointing your DNS to us. So when you're talking from like an architecturally, this is important because all you have to do to benefit from this security is, maybe it's point your proxies to us, point your firewalls to us, point the DNS for that to us, and you get that layer of security. If I was to ask if you have a firewall and I say, okay, I have 60,000 destinations I want to block, and I give those to you every day, eventually, you're not going to be able to take those at scale. And as I mentioned, as we're evolving, we started off as a recursive DNS company, OpenDNS, if you're familiar with that. And what we've done is we've kind of grown. We've added the DNS layer of security. We've brought in that correlated threat intel. We've actually made like an acquisition in the CASB space. And what we're doing is building out a secure internet gateway. So what we've recently also launched is a secure web gateway, where now instead of just doing the DNS queries, we can actually route all the traffic. So we'll see the full URLs that people are going to, not just the domains, and also a cloud-delivered firewall. So the idea is that the vision here is to kind of protect all the users for all the applications that they're accessing, whether it be on or off network, to provide these capabilities. And now I'll jump into a quick demo. Let's save this.
Let's see if we can just. Should just have to. I think we have to refresh this one too, just to get it to. This will come up in a second.
So this is the user interface for Umbrella. Completely web-based, located in the cloud. And how I typically start it is, how easy it is to get up and running. So you have various deployments that we talked about, right? So when I go to this deployments tab over here, this shows me the different deployment options. So depending on your organization, it may be you've just pointed your traffic to us and you registered that egress IP. You can download the roaming client, which will give you the attribution to a computer. We have the Chromebook support. What I'm going to show here is the network device. So this is where BlueCat's actually is actually using our network device API. So what they've done is you've generated an API key here, pasted in BlueCat, and now that device is effectively registered with us. It's going to send all those external queries to us and also pass along the additional attribution. So great, we have our traffic coming to us, and then what do you actually do with the traffic? You control that traffic with a policy. So this is where you can create different policies. What will happen is the policy at the top, the first policies that matched, is the one that will be applied. So if we just take a look at a policy here, we have a BlueCat policy. What you do with a policy is you select a set of identities to apply to that policy. So of course, depending on your deployment, that might be an Active Directory group. It might be Active Directory users. It could be iPhones. It could be the roaming computers. It could be an entire network. What we have here is the network devices. So this is actually saying, I'm going to set this policy for these BlueCat service points. Now we break the blocking into two categories. We have our security, and then we have content. So from a security perspective, the kind of most common categories that we have here are malware, command and control, and phishing. We also have categories for the newly seen domains. Right, so I have this conversation. I think it's interesting. We see 3 million newly seen domains every day. If you're running a manufacturing facility or some system in a hospital, is there really a legitimate need for it to access a domain that's new within the last 24 hours? Probably not. If you block your developers from going to this, they will absolutely hate you because everything they spin up in public cloud is always unique subdomains, unique instances.
But you're talking about an authoritative domain, not a subdomain.
Well, it applies to subdomains too.
Okay.
Yeah. So lots of times AWS will be, Amazon AWS or something with a bunch of unique stuff in front of it.
Right. Okay. So it is a problem in that sort of environment. Yeah.
Yeah, absolutely. You do not want to block the developers, and you can whitelist domains as well. We also have these, DNS tunneling. So we talked a little bit how you can identify tunneling east-west. We can do some of that tunneling identification as well, and then crypto mining. That's kind of an easy one as well, right? If you have a data center, probably shouldn't have crypto mining going on in there unless you're a certain type of company.
Unless that's what you do, right? Because that does exist.
You mean all of the blockchain
For
companies?
sure, but I'd say the large majority of
Yeah,
companies.
absolutely.
And every time I've worked with a customer where we have found crypto mining, it was 100% not approved, and it led to other things going on.
Fair enough.
Now, from a content perspective, it also becomes an easy mechanism to restrict content. So we have these 3 out-of-the-box levels: high, medium, low, or custom, and you can completely protect what you want to block here, right? This is pretty popular in like guest Wi-Fi instances, et cetera. So you can choose, there's over 80 categories ranging from German youth protection to pornography to terrorism, social networking, file sharing, et cetera. So those are the content. And then you have these destination lists, so you can always, of course, override these and say, this is a allow list, this is a deny list, I want these domains in here. And you can completely customize the block page, right? What's the experience that the user is going to see when they try to go to this page? And lastly, we were talking about the logging a little bit here. You actually have control of what information is being logged here, right? So you can say, I want to log all requests, or only want to log security events, or I don't want to log anything at all. And we also provide the option to, when we're logging this information, we can store it in an S3 bucket so that you can then bring it into a SIM or any additional analytics that you might want to do with it. So that's what a policy looks like. And then lastly, we have the reporting, right? What can you do with this information? So I think this is, I kind of started off with just top categories, right? So if you think of those 3,000 DNS queries, you could just start with something as, what is the top categories of sites? And then I can drill down on this to see which site is accessing this sorts of content, right? Or which specific user here. But we also have things like, the security overview, where we can drill down to see, okay, what are the types of requests that are being blocked by destination, by identity, who's actually blocking these bad sites? All these reports can be automatically saved and custom and emailed on a daily, weekly basis. I'd say we're pretty flexible there with like role-based access control and reporting. But one of the things I wanted to end on an end note is the kind of, when we're talking about the threat intel, I mentioned the 200 billion queries we see every day. We actually provide a system called Investigate, which you can actually kind of mine some of that information. You'll see it's very anonymized. But one of the things I like to do here is I can search, to give you an idea how live some of this information is. I just did a search here for PayPal.com, wildcarding it for the last 7 days, or saying, show me all the domains that are matching PayPal.com, right? And what's interesting about this is And this comes from the amount of traffic we're getting. So if you look at this guy right here, right, this domain is paypal.com.
Sorry, I tried to blow it up for you. Let me go.
Yeah, paypal.com.cgi-bin-source-update account center topnotchmanpower.co.cc or something, right? So we actually, the only reason this domain is here is because we actually saw that query hit our resolver, right? Now, and that's because of, again, the diversity of the traffic. It could be someone in an airport lounge, a coffee shop, a university, an enterprise customer, a free user at home, et cetera. And we saw that query hit our resolvers. Today's the 14th, right? Yeah, this is GMT. So we saw that query hit earlier, a little bit earlier today. Someone actually made that query. We've already categorized it as malware, right? And so you get that protection. So if you have a user that has some email or they're on a phone, et cetera, that's meant to look like, paypal.com, and with a shorter address bar in your screen, it's going to look a little more fishy, but you're getting that protection just by pointing those from a DNS perspective. And like another example, I'll do a very last thing just to kind of show the magnitude of the information. If I look up something like google.com, you can see some of the information that we have available, including the amount of traffic that we're seeing. So in the last hour, we actually saw 516 million queries hit our resolvers for google.com, right? So we can actually see the kind of Monday, Tuesday, Wednesday, Thursday, Friday with lulls on the weekend. And there is heaps of information here that you can use that tell you additional information about this, where the users are coming from, et cetera, IP addresses, ASNs. All this is also available via API to do integration with other systems.
Cool.
So how do you license Umbrella?
So Umbrella is licensed, great question. Umbrella is typically licensed per user. So it doesn't matter how many devices the user has. Lots of times it's like how many users in your Active Directory from a kind of really simple case. Yeah.
And BlueCat, how do you license that?
We also license it per IP address.
IP address. Okay.
Mm-hmm.
What happens when you get a classification wrong?
Yeah, so lots of times when we get a classification wrong, we have over 18,000 customers, right? Chances are someone else is finding out about it as well. So there's two things. I mean, you can either open a ticket really quick, or what you can do if you're 100% sure is you can just whitelist that domain yourself, right? If you're like, I really want people to go here, that's those allow and block lists. Those will override everything else.
So we'll go through these last few slides pretty quickly. All of the slide content that we've gone over in the presentation will be shared with all of you, as well as I know Dana, who is our corporate communications manager, will reach out with you if you have questions and a way to engage the BlueCat team if there's anything that we need to clarify. So I started the presentation a little bit around DNS as a service and what we're seeing our customers move towards and how we're seeing it change overall. And what we're finding is, and what I hope you got through the various presentations, is that DNS is something that has changed and shifted over the years. It's coming from the cloud now. Customers want to do changes rapidly. They want to have it secured. BlueCat in general wants to and does continue to innovate in the ways that we manage the DNS infrastructure and DNS as a service. DNS data can be utilized for much more in an enterprise organization than what it is being used for today. So not only can it be used for a security perspective like Cisco had gone through, but we really want to focus on service health. So what can it tell individuals about their network, as well as application health? Is there something about the application that they should know about that the DNS queries would tell them about the application? So we'll focus on those two areas. So from a service health perspective, if you look at this data, and I know it's kind of an eye chart here in terms of the trends, but this was actually insights that we got from one of our customers, specifically related to the latency in their network. And so what we were able to map out was effectively how long was it taking for DNS queries to resolve, and what was the latency. The green and yellow lines are good. So both of those lines represent under 20 milliseconds of latency in order to get the query response back to the end client who made the initial request. Blue and orange, not so good. Anywhere from 100 to greater than 100, sometimes thousands of milliseconds to get that response back to the client. And from a DNS perspective, what would happen is you're going to get a timeout long before you get the resolution for the query that you have. And so what we saw was, as you can see, before September 10th, you could see that there was a lot of that increased latency in their network. There was a lot of blue in their environment. What this allowed us to do from the perspective of a service with this customer was reconfigure their DNS infrastructure and their path, their network path for resolution to address this latency. And so we quickly identified the issue with the latency, made small, minor configuration changes for them, and completely almost eliminated the latency here on the right that you see in the graphs. And so that change, by rerouting the way that they were doing it, it completely solved a problem that they didn't even recognize that they had in their environment. And so that's where we're seeing DNS being more than just query and response, or query response and security. It's becoming more and more in that environment. The second case that we have that we wanted to talk about the futures and what we see constantly evolving with DNS is an application situation that we saw with another customer. And so this one specifically was related to an agent that the customer had installed on their devices in their environment. And they installed it over 70,000 endpoints within their environment. This application naturally was very chatty. It did about 5,000 QPS, or queries per second, in the environment. So it was naturally a very chatty type of application. The customer didn't actually realize that. So immediately, just by putting in the edge service points, the customer went back to the manufacturer of this application and said, why is this so chatty? They didn't realize that they were all of a sudden going to get this network spike in traffic because they didn't expect that. More importantly, what we were able to identify was on August 24th, you'll see that there was a very big spike in data. And so their queries per second went from 5,000 to 13,000 immediately. And what the edge service point was able to do, and what BlueCat identified, was something happened. Something triggered this anomaly in behavior. And when we dug it down with the customer, and we were able to identify it pretty quickly in less than a week, but what we identified was that they had applied a patch to this specific agent, and that patch all of a sudden had a bug in it, and that bug increased their traffic almost threefold. And you're talking about queries per second, so take that, expand it over the time. Their entire network was having massive issues related to this one patch. And so a lot of what DNS is going to do for BlueCat, and what BlueCat's focusing on as a service and providing DNS as a service, is finding ways to use edge to really self-heal when these kind of anomalies show up in the data. Because after you trend data for a period of time with any of these customers, and the trend all of a sudden goes weird, you're able to start now analyzing what's happening. So in this case, we could actually see the specific queries that had gone up, and you can put in policies that I know both the Chris and Noel, the Cisco side, and on the BlueCat side, you can put in policies to help manage that. So you don't allow DNS now, and this one misbehaving client, patch, whatever situation, end up taking down your entire infrastructure and organization.